Okay, this is Matd1544 and 4.5 in the book about the identities. And remember now, in the beginning of the book, we already actually looked at the identities, which is then summarized over here in the little square block. And remember, we said when you look at the identities that comes out of Pythagoras, you must write them for you that you have them in all three the ways that you can present them. In other words, get them cos squared plus sine squared is 1, but also write it that you have cos squared, for instance, is equal to what? Sine squared and 1. And the same here, all three and all three. Okay, we have looked at that before. Now, when we do identities, it's always good to first of all change everything to sine and cos. This is just a way, but it works nicely. Then secondly, make sure that you make one fraction on the left hand. Well, if it depends on if you started with the left hand side and you started with the right hand side. But okay, so make one fraction. So one fraction by using your lowest common multiple and all that, adding, subtracting of fractions and all that we have done in previous units. And then once you have done that and you've simplified that fraction, then look at mostly two possibilities. Mostly, it's not always, but mostly. And that is, see if you can apply one of these identities now. Is it an identity? And then apply it, or factorize. Or factorize. And then you will simplify again and you will compare. Okay, I'm just going to say simplify and compare, etc., etc., and see what you must do then. Now, remember, we look at the complicated side, the most complicated side, and we start there. But it's sometimes good to do the left-hand side and the right-hand side. Sometimes I like to divide my page into two. Do like the left-hand side down here, and do the right-hand side down there until I get the same. Sometimes that works quicker for me. But okay. So if we look at the example here, we have changed the cot to cos over sine, and cos over sine, and then we see that should, this is cos over 1. Maybe I could just write there cos over 1. Okay, so that gives us the cos squared over sine. Now make one fraction, and then you see the top becomes an identity, cos squared plus sine squared, which is 1. It forms the identity, and then quickly we can finish the identity. Okay, so same here. Everything is already in sine and cos. Make one fraction. Now it's not an identity, so factorize, and we get to the end there. Okay, here we see that we need to do both the left hand side and the right hand side. Change everything to sine, and cos, of course. Change everything to sine and cos. Go down, compare the whole time until you get the same. Okay, so this is also a lot of pre-knowledge, and yeah, we're just actually revising it. Also this compound formulas was done in school. Just check that you know that the tan is now new, because some people do it in school and some not. So make sure that you because it's new for you. We like to ask the tan because to make sure that you're going to be, well, we ask everyone, but we like to ask the tan to make sure that you can apply it. So remember now, sine alpha plus beta is not sine alpha plus sine beta. It is this formula, sine cos, sine cos. So sine is always sine cos, and cos is always cos cos, sine sine. And sine works with the sine. So what I mean by that is, if you've got a plus there, you're going to have a plus there. If you've got a negative there, you're going to have a negative there. Cos works against the sine. If you've got a plus there, you're going to have a negative there. If you've got a negative there, you're going to have a plus there. So it works against the sine. And then tan is tan alpha plus beta is not tan alpha plus tan beta, like some people do. Tan alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. Remember, there is a little multiply there. So with the sign at the top against the sign in the bottom. With the sign at the top against the sign at the bottom. So if we now have something like this, this is now the NB stuff. That's the formulas that we must know. This is now the NB stuff. This is what you would expect now in a second test or in the exam and so on. So the hint here is, it says there, without a calculator. So my question should be, how do I do 75 now without a calculator? And then I must realize it has to do with this compounding, putting together. What must I put together? Angles that I know I can find the sine and the cos and the tan of, and that's my special angles and my special triangles. So I see 75 is 45 and 30, and then I apply my rule, tan plus tan, 1 minus tan, tan, just fill it in. If you get to up to this point in the exam, you can stop there. Okay, now, even more important, I think, for the specific course, we introduce actually radians to you, because remember, we do the trigonometry to introduce radians to you. That's why we do it. So radians will be important. But in this case now, if you have 7 pi over 12 and you see it's 105 degrees, in other words, you can convert, and then you use the 60 and the 45, it's going to be fine. If you put it back to radians, like in this example, pi over 3 and pi over 4, it's also fine. So yeah, it doesn't matter how you go about it, as long as you can use your special triangles up to the end. This is just special preference. So if we are busy trying to learn the radians, I think it is best to stay in radians, but it's not really a problem. So cos pi over 12 without a calculator. So I see this is 15 degrees. So then I must now ask myself, how am I going to get 15 out of the angles I know? So it's 60 minus 45, or I could also take 45 minus 30, and then I can do whatever I need to do. So this is an important example. Okay, where we use Pythagoras again. Sine is that, cos is that, sine is that, cos is that, and now they ask us these compound angles, you see. So now you will have to draw your little diagrams in the correct quadrants and find the correct values from it. I will later do another example here, but this type is now important. So here we have a class activity that you can go through, which I think will be good. Let us just do number 7 together. So here we have the tan of 7 pi over 12. Okay, so now I need to see what is 7 pi over 12. Okay, and I see it is 105 degrees again. So I can now, if I want to write here, that is the tan of 105 degrees. Okay, and that I know is 60 plus 45, so I can just go tan 60 plus 45. I do not need to go back to radians if I don't want to. Okay. Right, and now I must apply the tan formula for that. It's 45 there. Okay, so it's the tan 60 plus tan 45 at the top with the sign, at the bottom against the sign. So 1 minus tan 60 tan 45 tan 45. Okay, go to your special triangles that you need to always show and find what you should find there. In other words, what is the tan of 60, etc., etc., etc. from your triangle. So tan 60 square root 3 over 1, but we can just write square root 3. Tan 45 is 1 over 1 minus square root 3. And for this course, we can stop here. It's also pre-knowledge to remove the cert in the denominator, but for this course now, for this part of the work, we can just stop there. That will be okay. All right. Then also very, very important is the double angles, all the double angles. Okay. So in other words, formulas. And that's a formula. We just apply the formula. So, but it's also done in school. So sine 2 theta is 2 sine cos. Cos 2 theta has the three different forms. Cos squared minus sine squared, 2 cos squared minus 1, 1 minus 2 sine squared. And then the fifth one here is the tan, which is now new. So tan 2 theta will be 2 tan theta over 1 minus tan, so it's going to be tan squared. Okay, what I want you to write in for you is, if you just have sine theta, cos theta, because this pops up so regularly, and people are supposed to realize what it is, but they don't. So understand that if we only have sine and cos next to one another, that is always a half sine 2 theta. It's very logical, but it's just good to have it available. It's always a half sine 2 theta. Like here we have one of those. You see? Here we just have a sine and a cos next to one another. So there's the sine and the cos next to one another. Okay, so that gives us a half sine 2 theta. So it's a half sine 2 theta, which is then a half sine 30. And now back to, remember, it's always without a calculator. Without a calculator. So back to my triangles. It's not really difficult. It's not really difficult. Let us look at together at this number B. So we have here 4 tan. So now I need to realize that the tan formula has a 2 there, not a 4. So that means I have 2 tan. Sorry, let's just get back to the sum itself. So in other words, I have 2 times 2 tan. Okay, 22,5. All right, over 1 minus 10, because this is over 1. That's why the bottom stays as it is. No problem there. Okay, tan squared, 22,5. Okay, and this I know now is the double angle. So that's going to give me 2 times the tan of double 22,5, which is 45. And tan 45 is 1. So this is going to be 2 times 1. And that's going to be 2. Okay, here I have 2 sine cos. So this is going to give me, I realize 2 sine cos, same angle, it's the double angle, so this must be the sine of 2 times pi over 8, that will be pi over 4. That's 45 degrees, and the sine of 45 degrees is 1 over square root 2. Okay. 1 minus 2 sine squared, I realize that this is the double formula. I find it often that people in exams confuses 1 minus sine squared and 1 minus 2 sine squared, because they don't know their theorems, the rules. I saw in the test also, it was so interesting to see that the people that went through the 7 steps doing that graphs, the tree graphs, the sine and cos graph, do their 7 steps that we did so thoroughly in class, got 100% for those graphs, and the other people who did not do that, well, they get about 4 out of 10, 3 out of 10 every time, because it's the graph is totally wrong. So, you know, some people want to learn, some people don't have the desire. They're not honest about their choice of career yet. It's a pity. But I think, and we cannot blame it on COVID or blame it on, because it has to do about desire. It doesn't have to do about the circumstances. Alright, so 1 minus sine squared is cos squared. And 1 minus 2 sine squared is sine 2 theta. Totally different. Okay, so I need to realize that. So 1 minus 2 sine squared is then the sine of double. I'm sorry, 1 minus 2 sine squared is cos 2 theta. Oops. Not sine 2 theta. Where's my pen now? Yes, I've got it now. This is cos 2 theta. Sorry. The one is cos squared and the other one is cos 2 theta. So let me just go back here. Apologize for that. So 1 minus 2 sine squared is the cos of double. So this is the cos of 7 pi over 6. Now I must go on with my rules that we have done. So where is 7 pi over 6? That's in the third quadrant. So therefore it's minus the cos of the reference angle, pi over 6. Okay, pi over 6 is 30 degrees. So this is going to be minus square root 3 over 2. Okay, so again, very, very important, the solving now. Alright, it was also not handled very well in the test. So cos theta is sine 2 theta. Remember, we always change the 2 theta so that it becomes theta. So in other words, we're going to change the sine 2 theta now here. Okay, and then we must see what we have. Okay, so here we can factorize the cos. Common factor is cos. So we can take out the cos. So therefore we see that cos can be 0 or sine can be a half. Now if sine is a half, then, and it's between 0 and 2 pi, then it means it's just the normal quadrants. So that means then in the first or in the second quadrant. I gave in the test minus pi to pi. It means you had to do the plus k times to see what is in and what is out. There were 4 angles in both questions. There were 4 angles that were correct. Some people didn't get to the angles at all. Some people that only had 2 out of the 4 because they did not do it properly. Alright, so again here, there's the 2 theta. I must change it now. Now I just want to go back because I was waiting for this example to explain this here. We said here that cos 2 theta has 3 different applications, 3 different formulas. So what we do when we change is we look at what we have in the other part of the sum. So in other words, here we have cos 2 theta and here we have sine. So therefore, we're going to use the one that has sine in it. So we're going to use the number 4 here, so that we can have everything in sine. Alright, and then it becomes a trinomial. So sine is minus 1, or sine is a half again. And it's just in the normal 4 quadrants, so this is easy to solve. It's going to be minus 1 is only going to be at 270 degrees, or 3 pi over 2. A half is 30 degrees, or of course in the second quadrant, pi minus the reference angle. So pi minus pi over 6, which will be 5 pi over 6. Okay, so that is then, if we solve the equations. Right, so let us just do the 2 here together. Okay, so we're going to change, let us change this now to minus pi and pi. Let's change this now to minus pi and pi, for instance. So let's say that was not asked in. Okay, so first of all, I cannot work with 2 theta and theta. I have to change them. So I'm going to change it to 2 sine theta, cos theta, minus sine theta is 0. Okay, so I'm going to take out the sine. It's actually the same one we had at the top, but it's okay. That's why I changed it a little bit in the domain, basically, the domain. Okay, so 2 cos, 2 cos theta, yes. Just check me on this, minus 1. So sine can be 0. Or cos can be a half. Cos can be a half. Okay, so reference angle is 0 here. And remember, we're busy with radians. So the reference angle here will be 60 degrees. So this is pi over 3. Okay, now I need my quadrants, but for 0, we know that the sine graph for 0 repeats from 0 every 180 degrees. So that one is easy to write. So theta will be 0 plus k times pi, because it repeats every 180 degrees. Here we've got positive in the first or in the fourth. So here I must write theta is, now in the first quadrant, I take my reference angle, and this is plus k times 2 pi. And in the fourth quadrant, it is 2 pi minus the reference angle. So it's 2 pi minus pi over 3. That is 5 pi over 3. So theta is 5 pi over 3. 5 pi over 3 plus k times 2 pi. Okay, so that's now the general solution. Now I need to find the specific angles because I've given a domain. Some people stop there in the test. So we said in class, use the curly brackets or just write the answers, or use the curly brackets if you want to give all your possibilities. So between minus pi and pi will then be from here to here. So it's going to be minus pi, 0 and pi for this one. Because, so it's minus pi, 0 and pi. Now I need to take pi over 3. Pi over 3 is going to be in. Because that, remember, pi is 3,14 something. So minus 3,14. Just if you need to check, you must be just careful there. So pi over 3 is in. Now if I add 2 pi to it, it's going to be out. So if I minus it, so if I take now pi over 3, oops, sorry, just get my calculator running. If I take my pi over 3 minus the 2 pi, still not right, pi over 3, okay, minus 2 pi, I'm getting negative 5 pi over 3, and that is negative 5,2 something. It's out, so that's the only answer there. And then 5 pi over 3 here is also out. So let us, because it's more than 3,14, so let us do now 5 pi over 3, 5 pi over 3, and we do minus 2 pi. Minus 2 pi, because it's going to repeat every 2 pi. I'm getting minus pi over 3, which is inside, so that should be our answer. We can therefore say plus or minus, maybe there, and stop now, because that's going to be my 4 answers, or 5 answers, 1, 2, 3, 4, 5 in this case. Okay, in the test, all of them had 4 answers. So here, we need to go to the sign. So I gave this one just that we can revise. It's not always the 2 theta thing. So here we're going to make it 1 minus sine squared. We're going to use the normal Pythagoras identity. So 1 minus sine squared theta, or Pythagorean. And then I need everything into one function. So I go to sine, because I always change the square. Now after I've done this, make one trinomial. I'm going to move to the other side. So this is sine squared, that I get a positive here. I don't want to struggle with a negative. Sine squared. Then that is also going to the other side. So it's plus 3 sine theta. Okay. And then I have 1 minus 3, well that is minus 2, but if I move it over, I'm going to have plus 2. Right, now I just make a little star here, because I just want to warn you, it's not always going to have factors. Then we need to use the formula, the normal quadratic formula, minus b plus minus the square root of b squared minus 4ac over 2a, that one. Just to make sure we find all the answers for sine. But yeah, I think we're going to come right with sine theta plus 2 and sine theta plus 1. I mean, we're going to come right with factors. Okay, plus 1. That just is 2 and 1 is 3. 2, yes, everything. I think we're fine. So this gives me sine theta is negative 2. And this gives me sine theta is -1. Oh, we did the negative in the earlier sum. Okay, now, can sine be -2? No, because the amplitude of sine is 1 here. Can never get to -2. The central position, it cannot get to, I mean, just sine theta, we know it's on the x-axis, so it can never get to -2. So this is not applicable at all. So I just need to find the solution of sine theta -1. Now once again, if I draw my sine graph, I see there's only one place where it can be -1, and it repeats every 2 pi. So that is at 3 pi over 2. So therefore theta is 3 pi over 2, 3 pi over 2 plus k times 2 pi. And k is an element of z. But I need to give my answers between a minus pi and pi. Now remember, if I go on here, okay, that is going to be minus pi over 2. So that looks like the only answer I'm going to have. Now if I also take my 3 pi over 2, 3 pi over 2, and I minus, sorry, I mean if I take, 3 pi over 2, yes, is correct, 3 pi over 2, what I have, and then minus 2 pi from it. So if I take 3 pi over 2, and I minus the 2 pi from it, I do get my minus pi over 2. So therefore, the only solution I'm going to have here, between minus pi and pi now, is minus pi over 2. It's going to be minus pi over 2. That's going to be the only solution if I have to give my answers between minus pi and pi. Okay, so this concludes actually this unit 4. I just want to go back here now and just ask you, and remember I told you you can load it up into Jamboard and I'll look for you at it if you send me your messages and so on. I think it's now good to go back to, you can just find it here, just for the final little thing here, to go back to this exercise now and just go do the quadratic ones and the 2 theta ones and things like that. In other words, you know, especially I would say number 5, number 6, maybe, yes, number 11, number 7, you know, there's a 2 theta and there's squares and so on. I think, of course you can also do 4, but I think it's very good, will be very good if you can just go over that exercise again, because actually that exercise should have been repeated here at the bottom, and I unfortunately did not do that. It should be at the bottom of this again, where we are now, just so that we can exercise some more quadratic ones. So it should have been here again before we get to the calculus. So I think it's important that you just go over that, and then we will later on, of course, revise this again, because this part will be in your second test. If there's going to be a second test, we will announce everything, don't worry, but otherwise definitely in the exam. Okay, so that concludes then unit 4, and we will then, the next recording or so will be then on unit 5, which is the calculus, introduction to the calculus.